Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video today is the final day of the 2021 Advent of Code, Day 25, Part 1. The problem is called Sea Cucumber, and it looks like I'm about 5 days behind, but at least I got Part 1 done and I finally had some time to look into it. And of course, that is not what we care about today. So, I was happy to see, relatively speaking, that the problem was simple to solve. There's nothing that's relatively simple, especially when you get to the final days of Advent of Code. But it was not a 2-hour slugfest like some of these have been, or some of these have taken quite a bit of time, even for the best of the programmers that are doing this competition. So the sea cucumber. You start with a data set, and it's hard, like, to me, these are two different species. We've got one herd of sea cucumbers are trying to go east, and one's trying to go south, and they're all trying to, basically they're all on this thing, and they're all moving around, and the whole point is, how long will it take? How many steps will it take them to basically get themselves into a position where they're all happy, I guess? Are they happy, or are they not happy? I wasn't paying attention. Where they basically stop moving from you want to think from step to step or generation to generation. So if you can move right, you can. If you can move down, you can, but you always go right before you can move down. The ones that go east always move before the ones that go south. So you go east, south, east, south, east, south, until there's nothing left. Until nothing can move. So the tricky part about this was to break everything up into two separate data structures. The ones that go to the east have to be sorted basically by the x values, so that for every row you always handle the ones, this one before this one, the ones to the left before the ones to the right, because the ones to the left don't get to go, but then the one to the right does, and then the next frame they maybe both get to go. And the same with going down. So like if there's one after another here, this guy will not get to go, but this one will on a given frame. So for the ones that go to the right, you gotta sort by x value, and then the ones that are going up and down, you need to sort by y value. And so that is the tricky part about all this. And then they give you all these little rules and all these things. And I chose C++ for this just because why not? I've been kind of on a C++ kick the last couple days. Python gets me so far, and when it came to unsorted versus sorted data structures, it's frustrating a little bit for me that the dictionary and the sets are unordered. Like there are unique values stored in there, but they're not necessarily ordered in any specific way, or in a way that I guess makes sense to me, a sorted way. So anyway, so here is my code, and so it couldn't be any easier than this, right? So process the data file. My data file is humongous. There's a whole, how many? I don't know how many. There's 137 rows, and I don't know how many columns. Let's see, what do you got? About 140, 139, 140. So it's a pretty big stretch of land there for these creatures. And so basically just say process the next generation until this function will return a false, meaning there doesn't need to be another one, because the next generation is the same as the last. And if it is one time, it'll be forevermore. Print out what's going on and call it a day. So that's the main is relatively simple, but two functions, and of course process. Before I can process, though, I set up a coordinate class. You could have been a structure if you wanted it to be as well. So here is my basic constructor that sets up the x and the y value. Here is my copy constructor that sets up the x and the y value, and then here are the data members, the x and the y values themselves. And so I was looking into this. There's at least 3 different ways to go about setting up because I used a set for this and for both of these guys, and to set up the comparison. And I chose the old functor method here to get things done. But there's a 2011 method. There's a way of doing things. There's a 2020 way of doing things. And I just felt more comfortable, at least in just getting this thing done, falling back on the things that I know, and I know how to do a functor. So basically, this is a class that takes over this operator, so it can be used by the standard template library to do the sorting that needs to be done. And so this is just a fancy thing that just says, let's sort by x value first, because I'm doing compare by x. And so it's sorting by X value. If it's less than, it's a true. If it's greater than, it's a false. Otherwise, let's go to the Y value. And the same thing will go here, just in reverse. Compare by Y, tests the Y values out first, and then it goes to the X's if it needs to. And and then using these things, here you go. Basically, if you've never used the second parameter for inside of the template here for the set, you're in for a treat, because that's definitely what happened here. This is saying take my set, a bunch of coordinate objects, and use this guy to do the sorting, or use this guy to do the sorting for the ones. And again, I call them easties and southies. So the ones that go east are in this set, and the ones that are going south are in this set. And we can work them both together, as you'll see in a minute here. And we need the width and the height so they wrap around. So the ones that when they fall off, they, like Pac-Man, they come back around on the other side. Same with the south, they come back around on the north. So let's see, there is my function for processing the data file. Open the data file, get a line for every character. If the character is an eastie, put it in the list or the set. If it's a southie, put it in there, and then just keep on going. And I'm maintaining the XY values as I go. Y is technically height here, and width and height if you want to think of the X and the Y values. But that's how I'm covering that. So then at the end of the day, those values are stored in basically YX order here, because this guy is 0, 0, but this is 2, 0. This is Y of 2, X of 0, and that's just how I think of it. Just do the Y value first, and then before you do the X. Okay, so that's all that there is to this. So then I have two sets of data, literal sets of set of data here that are all these coordinate classes, and they're all organized in the ways they need to be. So I can show you by running the program up to that point. All right, I was wondering if this thing would build. Here we go. So my easties, I have 4,724 of them, and it's hard to see. But again, these are sorted by Y value first, and then if there's a need a tiebreaker, we sort by X. And there will never be two values. It's a set, so there'll never be two values that are the same. So then here we go. So 8, 15, 24. And again, I want to go low to high so that if I test out like 51 here, that one won't move, but the 52 will. And so forth and so on. And the same goes for southies. There's 4,809 of these guys. And then these are sorted by X value first and then sorted by Y second. And it's the same idea. This one won't be able to move, but this one will. Okay, so this is just getting the data into a format I can work with. And then the processing is not hard per se. But so here we go here. So this is how you do one at a time. So I've got one generation to the next, and you don't process the whole thing one at a time. When you go east, once everybody goes east, then when everybody's going south, you use that new data. A lot of times you kind of use for the whole generation. You go ahead and set everything up appropriately so that you wait until the entire next generation. But this is one step is considered two sub-steps, but each sub-step is considered a step. It's a whatever, however you want to think about it. So all I'm doing here is saying, okay, for all of my easties, for everybody that wants to go east, can I go east? So set up a new coordinate, 1 unit to the right of where I want to go, and mod it with the width, just so if I get that wrap around, that I get comes back to 0, and then check to see if it's in an either or both of the easties or the southies already, because if they're already in there, then I can't move. And that's all this is saying here. If I can't find it in the easties and I can't find it in the southies, then I'm going to be able to move, and then I put that new coordinate in there, and then this is where I say continue processing equals true, because if I move one guy, that means that basically I'm going to have to do a whole nother generation to determine to determine when this thing stops. Because again, if one movement is all I need for this thing to need to have a whole nother generation. But otherwise, if it's in either one of these lists, then I just insert the coordinate I already am at because I can't move. So this is basically say move if I can, and otherwise put it in there as is, unmoved if I can't. And so I go through all of the processing with that, and then I just take whatever the next generation is and I move it into the current generation. And I do the exact same thing here for the southies, except I change the height and the the y and the height, and just go, okay, can I, basically, if I tried to go down, would I hit something? And if the answer is no, then I'll pop it in with the new coordinate. And if the answer is yes, then I will pop it in with the old coordinate. And then just do, and then return continue processing, and just coming back again. You see here, you get everything that you get. So when you run this program, did I hit a breakpoint? Am I running this? Nope. When you do run it, you get this. Part 1 solution, for at least for my data, is 414, and that is what I get down below here. So there's 414. And for part 2, I have never made it this far. I've never gotten part 1 of the final day, and basically I'll need 50 stars to boost it, and essentially because I haven't gotten all of the stars up to this point, all 49 of them, that it won't let me finish and get whatever reward. And I don't, until I ever get the reward, I don't want to know what it is, because I don't want to be disappointed, I suppose. But anyway, so there's no way for me to continue part 2 until I solve 7 other puzzles or 7 other parts of problems here. And as you can see, I've got a little bit more to go if I want to, but I'm hitting the new year here, and I want to go. I need to move on and do bigger and better things, quote unquote, here. So thanks for sticking it out with me as always. If you have any questions or concerns or a better way to do things, I'd love to hear it. As always, it's the new year for me anyway, so happy new year, everybody. End of 2021, the beginning of 2022, and I hope you have a restful and peaceful winter break, and I'll see you guys in future videos. I definitely plan on upgrading my older videos and continuing on making newer videos. So take care, everybody. I'll see you then. Have a great day.